Hello and welcome to the Mind IDE channel. So as this is the first actual content video on the channel, I just wanted to start with something that's kind of a fundamental concept. So I figured we would start with binary numbers. So we're just going to look at a couple of things. We're going to see what binary numbers are and do some simple how to do binary addition, and that is about it. Oh, and of course, converting from binary to decimal, because that is important. So what is binary? Well, you're probably familiar with decimal. And decimal is base 10, and binary is base 2. So what does that mean? Okay, so when you have decimal, this is what people use on a daily basis. 5, 6, 7, 8, 9. And then what happens when you get to 10? Well, we don't have a number that just means 10. That would be in this column here. So we roll back. Actually, I should have started this from 0. We roll back to 0, and we put a 1 there. And then from there, we would go, so 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 8, 1, 9. Right? And then when you get to 19, you roll this back to 0 once again. And we increment this column to 2. So it's just like you went from 1 here to 2, right? Now that should seem very dreadfully obvious and maybe mind-numbingly so, but I'm just trying to set this up so that you know what we're doing here. So this was base 10, right? Base 10. In base 10, where did we roll over when we hit 10? And then we count up, and when we hit 10 again, we roll over once again. So now with binary, it's the exact same concept. We start at 0, 1. Now it's base 2, so we rolled over at 10 last time. So now we roll over at 2. So base 2, we roll over at 2. And then we would go here. So 1, 0, 1, 1, right? And then we roll over once again, 0. And then because we have 1s here already, we're going to roll over here, and we're going to go there. Okay, so hopefully that kind of makes sense. Basically, anytime you get to 10, or anytime you get to 2, which would be the equivalent of getting to 10 in decimal, we roll over. So now you might be wondering how we're getting that. Okay, so we're going to go into addition, and hopefully that will make sense. Or sorry, we'll do a simple binary to decimal. All right, so if we have 0, that is 0. If we have 1, what is that? Well, that is going to be 1. And this, which is 0, 1, is the exact same thing, is 1. Okay, so now how do we go from there? So what you can think of with binary is basically we have different points here. So whatever is in this column, if it's a 0, then we have 0 times 2 to the 0. This is the 0. Let's think of this as this. So 0, 1, 2, 3, and so on. That would continue on. So 4, 5, 6. So whatever you have in this column, okay? So if you have a 0 there, 0 times 2 to the 0. This 0 coming from there. All right, if we had a 1 here instead of a 0, it would be 1 times 2 to the 0. Again, that's from there. So this could be a 0 or a 1. So 0 times 2 to the 1, or 1 times 2 to the 1. And again, this 1 is coming from here. This is coming from here. And you just keep continuing on and on and on. So what does that mean? Okay, so with this number here, this is 0. So we have 0 times 2 to the 0 plus 1 times 2 to the 1 plus 0 times 2 to the 2 and plus 1 times 2 to the 3. So that's 0 plus 2 plus 0 plus 8, which is 10. So that's how you convert this 1010 into a decimal number. So we can do the same thing here, which is 0 times 2 to the 0 plus 1 times 2 to the 1 plus 1 times 2 to the 2 plus 1 times 2 to the 3. So 0 plus 2 plus 4 plus 8, which is 14. And so on and so forth. So then this one, we'll just move this a little bit. Zero times 2 to the 0, 1 times 2 to the 1, 1 times 2 to the 2, 0 times 2 to the 3, plus 2 plus 4 plus 0, which is 6. So that's how you can convert binary to decimal. So all you have to do is look at the spot. So you just look at your first location, which is going to be 0. These are your index locations. You can think of it that way. And all you're doing is 2 to the whatever index location. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And if there's a 0, like in this case, this one is nothing. And then if there's a 1, it's just 1 times that. So you can go 2 to the 1 plus 2 to the 2 plus 2 to the 3. So very, very simple. That's just how binary works, right? It's the same as when we go back here. This was base 10. So all we have to do here is, so say you have 1, 1. This would be 1 times 10 to the 0, which is 1. This is 1 times 10 to the 1, which is 10. So then you would have 10 plus 1 is 11. So that's if you're doing it in decimal. But you could do that for any number. So like 4, 5, 6 equals 6 times 10 to the 0 plus 5 times 10 to the 1 plus 4 times 10 to the 2. which is, this is equal to 6 plus 50 plus 400, which is obviously 456. So really base 10, base 2, it's the same thing. It's just you change your base here that you have, right? Or that looks like an equal sign. You change your base that you have. Binary, it's the exact same thing. Just your base is different. So this is 2 to the 0, which equals 1. And 1 times 2 to the 1, which equals 2. So then in this case, you would have 2 plus 1, which equals 3. So I hope that makes sense. It's that's how these bases work. But you can do this for anything. You could have base 3, 4, 5, really anything that you want. And it all works exactly the same. Just look at whatever your base is, and that will be pretty much what your rollover point is, and that will be the base that you use, that you raise to the exponent, with the exponent itself, this number, being your index point. And just keep in mind that your index point always begins with 0, this here. Right? So your first index point is 0, then 1, then 2, then 3, and so on. So it's really quite simple to convert binary to decimal. And I hope that makes sense to you. If you have any questions, definitely leave it in the comments. And then we have binary addition. So now that we know how to convert, we can look at this and we go, okay, so realistically, we know that this is going to be 1 and 1, which should be 2, right? If we were doing this in decimal. So let's see if that checks out. Okay. So all you got to do when you do binary addition, it's really quite simple, is keep your rollover. So 1 and 1, 0, 1, 1 plus 0 is 1, 0 plus 0, 0, 0 plus 0 is 0. And if we do this again, where we have 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3, we add these up, so 0 times that makes that go away, 0 times 2 to the 2 makes that go away, 0 times 2 to the 0 makes that go away, so we just have 2 to the 1, which is 2. Which is the same as what we have down here. So that checks out. Okay. Now, why, when we have 1 and 1, does it become 0 down here? So it's the exact same thing as, let's say you had a, again, if we're looking at this the same as decimal. So if you had 9 and 1, or let's go 119 plus 2, 1. Okay. So again, exactly what I was saying before, how 2 is your base there. So now 10 is your base. So 1 plus 9 is 10, which means this is a rollover point, 0. And then we would put our 1 here, and then 1 plus 1 is 2. Sorry about that. 1 plus 1 is 2. And plus 2 is 4. And then 1, right? And then it's the exact same concept in binary. Just get rid of that so we're not confusing. Okay, so 0 plus 1 is 1. 1 plus 1 is a rollover point because it's 2, right? 2 is our rollover. We can't have a 2. We got a rollover. 1 plus 0 is 1, plus 1 is 2. We can't have a 2, so we got to put a 0 and roll over. 1 plus 0 is 1. Then 1 plus 0 is 1. Now, this is where things get a little bit odd. Basically, there's two different kinds of, there's two different kinds of binary that we can consider. There's unsigned and there's signed. And all that means is if you have signed, your first digit determines your sign. So in this case, if we don't want to change the sign, we just need to put a 0 here. If you had a 1, if this was signed binary and you have a 1 in this spot, that means negative. That means negative. So let's say you left it like this and you wanted to convert it to decimal. If this was signed binary, this would be 1 times 2 to the 0. Then these are 0, 0. And this would be a negative. So this would be -1. But that is not what we want. What we want to have is a positive number. So we add this 0 here, which means positive essentially. And signed, 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 or you can just leave it blank and just assume it's positive. So you would have 2 times or 1 times 2 to the 0. These are zeros. This is 1. This is 2. This is 3. So we just add that up. So we'd have 8 plus 1, which is 9. Okay, and this last one here, if we go 1 plus 1 is 2, so we put 0 because we have a rollover. And then 1 plus 1 is 2, so that is 1 with a rollover. Plus 1 is 1. 1 and 1 is 2. Plus 1. 1 and 1 is 2. Plus 1. And we can just imagine zeros here. 1 plus 0 is 1. Plus 0 is 1. And then we'll put this here just so that our first bit doesn't change the sign. And then we can go like this. This would be 2 to the 4 plus 2 to the 3 plus 2 to the 2 plus 2 to the 1, which is 30. And we can double check. So what is this one? Okay, so if we double check, let's just get rid of this. Just to keep this kind of clean. And we'll get rid of this. Okay, so if we have that, that's 2 to the 1, which is 2, plus this is 2 to the, just put these in brackets. So this first bracket here, this one, is this number. And this we'll do here. So that was 1 times 2 to the 0, 1 times 2 to the 1, so 1 times 2 to the 2, which is 2 plus. This is 4 plus 2 plus 1, which is 7. 2 plus 7 is 9. So that one checks out. And now what is this one? This is 2 to the, no, that's 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3, which is 1 plus 2 plus 4 plus 8, which is 15. So then we'd have 15 plus 15, because these are both the same. Both of these numbers are the same. So 15 plus 15, which is 30. So that one checks out as well. All right, so hopefully that was helpful. I think that the next video I'm going to do is converting decimal to binary. And then I might do, this is kind of the schedule here that I'm thinking. So decimal to binary is the first one. This one we could probably do in a single video. So that is 1's complement and 2's complement. And then we could look at other bases like hex and that kind of thing. And then this, I thought we could do write some code either in something like MATLAB maybe to actually do a binary calculation for you. And then I'm also open to suggestions. So if you want to see something else, just let me know. And that is about it for this video. Definitely please make sure to like and subscribe. This is the very first video on the channel, so anything like that would really help me out. And then also let me know what else you want to see, if you'd like to see more of these kind of videos, or if you want to move into something like physics or math or coding or something like that. Definitely let me know down in the comments. I would really appreciate your suggestions. All right, thank you so much for watching today, and until next time, take care.